Hello, this is Dr. James Camp, and this is the latest in Camp's C++ Quickies. Today we're going to talk briefly about some of the ways in which we do math in C++. So for this one, we don't need the string library. We're going to, in fact, take out most of our hello code here. I'm going to start new with int my int. Okay, remember an int is an integer number, no decimal points in it at all. Going to C out, pick a number between 1 and 10. We'll just do that for fun. Okay. We'll see in my int, and then we'll see out your number times 4 is my int star 4 end line. Okay, that's how you do multiplication in C++. Your number divided by 3 is my int slash 3. Okay, end line. That's how you do division in C++. The remainder of your number divided by 3 is, okay, my int percent 3 end line. So that's a special operator that C++ has, the C family languages, I should say. All of these mathematical operations work for any of the C family languages: C, C++, C#, Java, JavaScript. So maybe not as much with JavaScript. I'm not sure if it does integer math. Your number times 5 plus 3 divided by 7 is my int times 5 plus 3 divided by 7 in line. Okay. Now let's run this number. Pick a number between 1 and 10. Now notice I didn't put a space here after my, and this drives me crazy when people do this, so I'm going to fix this. Putting a space after, putting a colon or a question mark or something to indicate that you want input, and then a space there makes the program ever so much more user-friendly. So pick a number between 1 and 10. I'm going to pick 8. Your number times 4 is 32. Okay, your number divided by 3 is 2. The remainder of your number divided by 3 is 2. Number times 5 plus 3 divided by 7 is 40. Okay, let's see if this checks out. 8 times 4 is definitely 32. We should all know that from elementary school. 8 divided by 3, we should expect to come out as, 2.2 667 or something like that. But this is an integer divided by an integer, and when C++ or any of the C family languages do integer math, an integer divided by an integer must be an integer. So what we get out is simply 2. So to deal with the rest of that calculation, the C family languages give us this percent operator. So the remainder of 8 divided by 3, so 8 goes into 3 twice, that's 6. 8 minus 6 is 2, so 2 is the remainder. Now you may ask, why do we even bother having a remainder operator? How often does that come up? It comes up remarkably often. If you want to do something every 10 times that you run through a loop, taking the loop counter %10 gives you how many of those multiples of 10 you've done, or how far you are through each multiple of 10. So if I took loop counter %10 equals 0 as the indication that I wanted to do to output my variable, for example, if I was counting to 100 by 10s and I wanted to output every 10th number, that would work. Now let's look at this one. Your number times 5. 8 times 5 is 40. Plus 3 divided by 7 is 40. Wait a minute, that's not right. Well, it is right if you take into account mathematical order of operations. Okay. This times happens first, my int times 5. But this divide has equal priority with the times and much higher priority than the plus. So 3 divided by 7 will happen next. And 3 divided by 7, it's an integer divided by an integer, so it's 0. There's no decimal point in there. Okay. So what I want to do is put in parentheses that indicate to C++ what order I want the operations to happen. I want the plus 3 to happen before the divided by 7. So this time if I choose 8, 5 plus 3 divided by 7 is 6. That seems a lot more reasonable. Okay. 8 times 5 is 40, plus 3 is 43, and we know 7 times 6 is 42, so that makes sense. Again, however, we're only getting integer math. Okay. If we want to force this to do floating point math, we have to put a decimal point in this equation somewhere. And that promotes everything in the equation to a double type, and we get what we would expect. 5 plus 3 divided by 7 is 6.14286. Okay. The other way I could do it is I could make the original number a floating point number. I can make it a double. Remember from last video we used doubles instead of floating points because of the increased accuracy. I'm going to come through here and choose to rename my int as my double. And that's going to change that everywhere, and that's what I want. Okay. So pick a number between 1 and 10. This time, we should get some interestingly different results, right? Okay. There were build errors. Yes. That's because you cannot use the percent operator on a double. Okay. What we can do is we can cast it to an int. We can force it to be an integer, and that's an interesting result there. Okay. So I'm going to choose 8. And this time, my 8 divided by 3, because I made it a double, is 2.66667. Okay. So this time we did floating point division. Because this is a double, I don't have to pick a even number, though. I can choose 9.8. Okay. Notice that when it casts 9.8 to an integer, it doesn't round it up to 10. It just drops the floating point part, so it becomes a 9. And 9 divided by 3 has a remainder 0. Okay. So you've seen how to do some basic math there. What if we wanted to calculate something a little more interesting, like the volume of a cube with forgot my Cout statement. Volume of a cube with side my double would be my double cubed, right? Unfortunately, there is no power operator in C++. Okay, some languages have that, C++ does not. So we have to come up here and pound include a new library called cmath. Okay, and cmath gives us a function called pow for power, and power of x to the y, or x to the y power is pow of x comma y. So my double comma 3 would give you that. So if I pick a number between 1 and 10, I'll choose 4. The volume of a cube with side 4 would be 64. Okay, that should check out with your math knowledge so far in your life. What if we wanted to do, then say, the volume of a sphere with side with diameter my double would be, okay, what's the formula here? V sphere. I just cheated. I made up a number. Okay. So let's just want to show you that you can create intermediate variables here. Okay, double V sphere equals, okay, now we know the formula we're looking for is 4/3 pi r cubed. Okay, so how would we get that in C++? We could say 4 divided by 3 times, how do we get pi? Well, there is a trick for that. We can say pound define underscore use math defines, and if that is the very first line of code in our code, it has to come before any pound includes, then we can get a constant called mpi. Okay, for math pi. Okay, 4/3 times mpi times power of, well, we're using my double as a diameter, so my double over 2 comma to the 3rd power. Okay, and you can see how this takes all of this and assigns it to V sphere, and then I can take V sphere down here and use it in a cout statement. So let's see what happens if I choose, say, 3. Volume of a cube with side 3 would be 1027. Volume of a sphere with diameter 3 should be 10.6029. Okay. Now, it occurs to me that we really should, just to make sure that this, we had enough doubles in this equation that C++ was treating this as double math, but we really should put this as 4.0 divided by 3.0, just to make sure. Okay. And I ran it with 3 last time. I should run it with 3 again to see. Yeah, and in fact, that did make a difference. See, 4/3 came out as 1 instead of coming out as 4.33333. So this actually looks much more reasonable than the answer we got last time. So always use your mathematical intuition to figure out if the numbers you're getting look right, and if not, check for things like integer division that might be screwing you up.
Starwackos is right.
Okay. Other things you can get from CMath library. Let's take a little journey to c++.com/reference. And here in our C library is CMath, and you can see that there are trig functions, all the ones you'd expect to be there, hyperbolic trig functions, exponential functions. Note that log in almost every computer language means the natural logarithm. Log 10 is what you normally think of as log, is the common logarithm. There's also a log base 2 for what's called the binary logarithm. There's the power function we just did, square root, cube root. There's a hypotenuse function. You'd be amazed at how many times in doing engineering math you have to do the Pythagorean theorem. This has a more accurate or more precise way of calculating the Pythagorean theorem than taking 2 squares and taking the square root of them. And so you can get the hypotenuse of a triangle with sides x and y by calling hypot, H-Y-P-O-T. Okay, and then there are some functions for ceiling, floor, for trunk, or round. Round is probably the one in here that you would use most often, where you don't want to convert something to an integer by just chopping off all the decimal points. You want to actually round it to the nearest value. And there's a function absolute value that computes the absolute value of a function, which again, you'd be surprised how many times that comes up. Okay, so that's my short form on all the math you need to know in C++. Thank you for watching.